Bismillahirrahmanirrahim. Welcome, students. Our today's topic is rounding of data. This is the last topic of this chapter. We will start by defining and discussing the significance of rounding of data. And we will also discuss rules to round off the numbers. Rounding means replacing a number with an approximate value that has a shorter, simpler, or more explicit representation. It is a type of estimation that we do in everyday life using many physical quantities like while measuring length, distance, amount of money, etc. All the actual numbers are rounded off to the nearest possible whole numbers. So when we round off a number, we make it simpler by keeping its value close to the original number. There are several reasons to round off the numbers. Number one, whole numbers are easier to add, subtract, multiply, and divide. If you just want an estimate of answer, rounding off the number is a great way to simplify such calculations. In daily life, we do round off the numbers. I got these pictures of beautiful princesses from the net. So let's suppose you bought a dress for rupees 1578, and at a party, your friend, see your friend over here, she's asking you, "Oh wow, you're looking so pretty. How much? How much was it? Your dress?" And you forgot the real amount. That was 1578. So what would you say? It's 1600 rupees. You rounded off the number. Sometimes you just don't need extra digits and it's sensible to round the number. So in short, rounding a number gives us an answer close to the correct one, which helps us in solving hard problems. You might have been rounding off the numbers in your previous classes. Your teacher might have asked you to round off 36 to the nearest 10 or 374 to the nearest 100, and you might be making a number line, and then you would have been checking out the number is lying to which number, it's 400 or 300, or in case of 36 you might have been doing so, and your teacher might have been telling you the rules as well to how to round off the numbers. So let's see the rules, how rounding off can be done. First rule, if the dropping digit is less than 5, then the previous number remains unchanged. For example, if you are given this number 1.943 and I have asked you to round off to 3 significant figures. So firstly, the initial number, this is 1.943, you will see the number of significant figures, 1, 2, 3, 4. In the previous lecture, we did discuss the rules for significant figures. And it is the first rule that all non-zero digits are significant. It means they are countable. So there are 4 significant figures. And the question says that you have to round it off to 3 significant figures. So it means 1, 2, 3. You need this 4, but you don't need this 3. So the 3 is the dropping digit. You have to drop it, but you can't drop it like that. You have to follow the rules for rounding off the data. So you will circle 3, this is the dropping digit, and you will underline 4, which is the previous number. So since this dropping digit is less than 5, as my rule says, the previous number remains unchanged. So my final answer would be 1.94. And if I count the significant figures in this value, it's 1, 9, and 4. So there are 3 sig figs. Hence, my answer is correct. Second point, if the dropping digit is greater than 5, then the previous number is increased by 1. What does this mean? Let's see another example, 1.978. And I have asked you to round it off to 3 significant figures. All of these figures are non-zero digits, and non-zero digits are significant. They are countable. So in the value 1.978, there are 4 significant figures. And the question says you have to round it off to 3. It means 1.97. It means you have to drop 8. But you can't drop 8 like that. You have to follow the rule. You will circle 8, that is the dropping digit, and you will look at the previous number. You're going to underline it. Since the rule says that if the dropping digit is greater than 5, yes, my 8 is greater than the number 5. So the previous number is increased by 1. My 7 adds up, and I get the final answer as 1.98. 1.98 has 3 significant figures in it, 1, 9, and 8. Let's see another rule. If the dropping digit is equal to 5, then there are 2 parts to it. We will discuss the first part first. Then previous number is if E1 remains unchanged. If the dropping digit is equal to 5, then previous number if E1 remains unchanged. Let's see the example. 1.45, round off to 2 significant figures. Let's see, 1.45 has 3 significant figures, as these are non-zero digits, and all non-zero digits are significant. They are countable. You have to round it off to 2 significant figures. So 2 means 1.4. What about 5? 5, you're going to drop it, but you have to follow the rule. You will circle 5, this is the dropping digit, and you will look at the previous number. That previous number is an even number. You might have read about the numbers, whole numbers, even numbers, odd, prime. Even numbers, 2, 4, 6, 8. You follow the table of 2, 2, 4, 6, 8. So yes, 4 is an even number. So when you will drop 5, your previous number remains unchanged because it is an even number. So your final answer is going to be 1.4. And in this final answer, you satisfy the condition of the question. That is, you have rounded off the answer to 2 significant figures, 1 and 4. If the dropping digit is equal to 5, then previous number, if odd, is increased by 1. Let's see an example. 1.35. Round off to 2 significant figures. You have been given a value of 1.35. You have to round it off to 2 significant figures. Right now in 1.35, there are 3 significant figures. Rounding off to 2 means that 1.3. So 5 is the dropping digit, but you can't drop it like that. You have to follow the rules. Since the dropping digit is 5 and the previous number is odd. Odd numbers include 1, 3, 5, 7, 9, 11, and so on. So since 3 is an odd number, we will increase it by 1. So my final answer is 1.3. 4. Checkpoint. Let's see. Did you get the rules or not? 6.735. Round off to two significant figures. 6.735 has 4 significant figures, and you have to round it off to 2 significant figures. It means till 6.7. So you're going to circle 3. 3 is going to be your dropping digit. You have to follow the rules. Since 3 is less than 5. Since 3 is less than 5, the previous number remains unchanged. So my value is going to be, my final answer is going to be 6.7. And 6.7 answer will have 2 significant figures, 6 and 7. Let's see 2. 6.4215. There are 5 significant figures in this value, and you have been asked to round it off to 3 significant figures. It means you have to round it off till 2. 1 is going to be your dropping digit. You are going to circle 1 because it is the dropping digit, and you will underline 2 because its fate is to be decided. So 1, the dropping digit, is less than 5. So the previous number is going to remain unchanged. Your final answer is going to be 6.42. And it will have 3 significant figures in it. 7.841, round off to 2 significant figures. 7.841 has 4 significant figures. All are non-zero digits. You have to round it off to 2 significant figures. It means 7.8. You are going to circle 4 because 4 is a dropping digit, and you have to underline 8 so that we can decide its fate. Ah, it rhymes. 8 and fate. So 4 is your dropping digit, and 4 is less than 5. So the previous number remains unchanged. So your final answer is going to be 7.8. It will have 2 significant figures, 7 and 8. See the fourth question. 7.485. 7.485 has 4 significant figures, and you have been asked to round it off to 3 significant figures. It means 7.48. You have to drop 5. You will circle 5, and then again you will underline 8. Since the dropping digit is 5, and the rule, you know, if the dropping digit is 5, then we have to look at the previous number. It's odd or even. Since the previous number is even, 8 is an even number. It remains unchanged. So my final answer is going to be 7.48. 5.475, round off to 1 significant figure. 5.475 has 4 significant figures, and you have to round it off to 1. Very simple. It means you only have to keep 5, and the rest of the digits, they are not required. So you're going to circle 4, which is the dropping digit, and you're going to underline 5. Since 4 is less than 5, the previous number remains unchanged. So my answer is going to be 5. The final answer, 5. Sixth question, 7.235. It has 4 significant figures, and we have been asked to round it off to 3 significant figures. So 7.23 it means. So I'm going to drop 5, but I can't drop it like that. I have to see the previous number. The previous number is odd. And when the previous number is odd, according to the rules, you have to increase it by 1. So my answer is going to be 7.24. Summary. If last digit is less than 5, it's dropped. If last digit is greater than 5, it's increased. Last digit is 5. So previous digit, you have to look at the previous digit. Previous digit is even, it remains unchanged. And if the previous digit is odd, it is increased by 1. Okay, let's see the examples. 2.813 is rounded off to 2.81, up to 3 significant figures. 1.29. Oh, 1.29 is rounded off to, you have been asked to round it off to 2 significant figures. I'm sorry, there is an error. 2 significant figures, it means 1.29. 9 is the dropping digit, and 2, you are going to underline it. Since 9 is greater than 5, it means the previous number gets increased by 1. It's a typing error, I'm sorry. So your answer is 1.3. Your answer should have been 1.3, and 1.3 has 2 significant figures. Let me correct it. It's 1.3. Yeah, good. And okay, continue. Okay, and then 6.25 rounded off to 6.2. Yes, that's correct. 5 is your dropping digit, and the previous number is even, so the number remains unchanged. And over here, 5 is the dropping digit, and the previous number is odd. It gets increased by 1, so the answer is 6.4, 2 significant figures. Home assignment, revise the lecture, write a note on rounding of data. The note should include definition, significance, and rules with examples. If you still have any problem in today's lecture, you can contact me on my WhatsApp number shared in group. Take care, girls. See you in next lecture. Allah Hafiz.